For Algebra 2 with trig, we're looking at 2b.5 and 2b.6, doing a review to get us back focused on these topics. Lots of factoring. We look at number 1 and we see a trinomial. We notice that it's cubed. We notice that there is a y in every term, so we can factor out that GCF. By factoring out the GCF, we're going to drop down all the exponents by 1 degree. Now we can treat this as a normal quadratic factoring. What multiplies to be 72, what adds to be -6. So if you think about your little table that would make that, what multiplies to be -72, what adds to be -6, you know your two signs have to be different and your larger number has to be negative. So 1 and -72, 2 and -36, 3 must go into that also, -2, looks like 24, that still doesn't get us down to 6. 4 would go into that, 18, 5 clearly doesn't go into that, but 6 could go into that, -12. And those two numbers add together to be -6. So since this has a leading coefficient of 1, this table helped you identify what two numbers you're going to plug into your two binomials. A +6 and a -12. Looking at our next one, it is considerably different. Yes, it's a cubic, but we don't have multiple terms. We only have the two terms. So this is perhaps called the sum, because it's plus the sum of two cubes in this case. So if we have something that's being cubed and we have something else that's being cubed, we have a pattern that says that we can write it as a plus b, that's the cube root of each of those, square the a term, change the sign, multiply the two together, and square the b term. So that's the pattern we would use for the next three. Give that a try. When we look at 8m cubed, we can take the cubed root of that. That would be 2m. So we have 2m that's being cubed, and we have 1 that's being cubed. You typically might not write that line, but your brain definitely has to think that line. You're welcome. I would like you to write it. Then we notice the pattern that we have the sum of two cubes. So we are going to write our a term and our b term. Now our common mistake here is, how do you square your a term? How do you square 2m? The common mistake is to write 2m with a square. You got to write 2m times 2m, which is 4m squared. Change the sign, multiply the two together, and square your last term. There you factored it. You can check that work. We have 2m plus 1, 4m squared minus 2m plus 1. You can check that work by multiplying it together. 2 times 4 is 8, m times m squared. You add the exponents. 1 and 2 is 3. Then you take your 2m and you multiply the negative 2m. Gives you a negative 4m squared. And then you take your 2m and you multiply the 2. So that's not looking like what our original problem was. Then we're going to take our 1 times negative, actually 1 times 4m squared is a positive 4m squared. And a negative 2m. And a positive 1. Where these terms cross out, so that looks better now. It looks just like what we started with. 8m cubed. That was the original problem. So you can always check your work with factoring questions. You can go ahead and try this next one. All right, one thing we need to make an adjustment is up here in our rule, it looks like I left the 2 on the outside of the parenthesis. That 2 should be squaring the b, not squaring the parentheses. That's a little better. We squared the 1, we didn't square the parentheses. So in this case, the cubed root of 27, what times what times what? That would be 3a is being cubed. 10 is being cubed. So you know you're going to say 3a minus 10. You're going to square 3a, multiply the 2 together and change the sign, and square the last term. 10 times 10 is 100. When we're working with the sum or the difference of 2 cubes, it creates this trinomial, and that trinomial will never be factorable. You don't have to worry about also factoring it. We look at number 4. Number 4, we don't know the cube root of 192. 6 times 6 times 6 is 216, so it's not 192. 5 times 5 times 5 is 125, so it's some number in between 5 and 6. 3, of course, is not a perfect cube, so this is not the difference of 2 cubes. So what do? We can pull out our common 3, which is a GCF. So 3 times 64, that makes 192. Now we're working with the difference of 2 cubes. So go ahead and try that. So with this one, what times what times what makes 64. 4 times 4 times 4 makes 64. So you have this w, or 4w, that's being cubed, and you have 1 that's being cubed. So that's going to tell you, you're going to write 4w minus 1, square your 4w, change the sign, multiply the 2 together, and square the 1. Now we look at number 5. Number 5 is clearly different. Number 5 is not the sum or the difference of 2 cubes. This has 4 different terms. It's not a binomial. It's not 2 terms. It's 4 different terms. We can factor this one by factor by grouping. That means we're going to factor or group those 2 sets. We pull out what we can, which is an x squared. If we pulled an x squared out of those 2, that would be x plus 1. Bring down your sign. Factor out what you can. You see that that is x plus 1. There's nothing that can be factored out. There's no common term, but there's always a common multiple of 1. So we're just factoring out a 1 to hold that place value. That leaves us with x plus 1. What's inside your parentheses has to be the same. To be able to factor by grouping, that's the big test. If we are trying to factor by grouping, what's inside the parentheses is the same. Then you write your x squared plus 1, this term and that term, and then your x plus 1. Go ahead and try that with number 6. So because there's 4 terms, we're going to assume that we can solve this by factor by grouping. That means we're going to circle both groups. N squared. That leaves us with an n plus a 5. Bring down your sign. Factor out what you can, which is a 9. That leaves us with a n, because negative 9 times n makes negative 9n. Negative 9 times a positive 5 makes a negative 45. What's inside your parentheses has to be exactly the same, must be the same. So we're going to say that it's n squared minus 9, and it's n plus 5. So notice this one is n squared minus 9. This one over here was x squared plus 1. X squared plus 1 cannot be factored. There's nothing that factors to make this. Nothing multiplies together to make that. But in this case, this can be broken apart into 2 more binomials. N times n, a positive and a negative would give you 0 in the middle, and a negative 3 and a positive 3 would make negative 9. So since this is the difference of 2 squares, we can factor that, but you cannot factor the sum of 2 squares. And don't forget your third term. All right, now we're looking at to the 4th degree. We don't have any special rules for the 4th degree. But what we notice is that this 4th degree is followed up by a 2nd degree. So the 2 is half of the 4. So we can treat this just like it was a quadratic. We can treat this just like it was 3x squared minus x minus 24. The 1 is half of the 2. So since the 2 is half of the 4, we can treat it with that same pattern. So we're going to treat it just like a quadratic. And to do that, we would multiply our a term times our c term. This would be one way to do it. Factor by guess and check would be another way. But if you're not confident with guess and check, having a process is going to help. You know to multiply to be a negative, your signs have to be different. And to add to be a negative, your larger number has to be negative. So we run through all the different ways that we can multiply to be 72. And 6 times negative 12 gives us 72. So as long as the 12 is a negative, when you add them. Oh, no, not this problem. And we keep going to 8 and negative 9. Those add to be 1. So there's different ways to multiply to be negative 72. But if it's going to add to be negative 1, we're going to use 8 and negative 9. So we bring down our 3x to the fourth, bring over your 3x squared, your negative 9x squared, and bring down your negative 24. Now we're going to treat this as factor by grouping. So go ahead and finish this problem off. Right, it looks like this should be an 8. Sorry, this should be an 8x squared minus 9x squared. These two terms have to make that one. So maybe it said 3 because that was a 3, but the 8 and the 9. So we're going to factor by grouping, so we're going to circle our two groups. There's nothing we can factor out of that but an x squared. That leaves us with the 3x squared plus an 8. Bring down your sign. Looks like a 3 can come out of that. 3 times 3x squared. Negative 3 times a positive 8 multiplies to be a negative 24. Remember, what's inside the parentheses has to be the same. To be able to factor by grouping, those have to be the same. So we get x squared minus 3, 3x squared plus 8. Neither of those can be factored again. This is the difference. This is a perfect square, but 3 is not. We don't typically factor that. Come over to number 8. Number 8, we notice the GCF in that. That means all the terms are going to drop by a degree of 2. That just leaves a 1 at the end because you factored out the m squared. You got to leave that place value there, though. You got to put a 1. Now you could notice that what times what could possibly make 36. 6 and 6 would be a good way. There's multiple ways, but this would be my first guess. M squared and m squared. Of course, what times what makes 1? That has to be 1 and 1. And we can add to become 12 by saying positive 6 and a positive 6. So m squared, 6m squared plus 1, and that is a perfect square. So we had a perfect square trinomial. We factored it apart to try to find that. All right, when we flip it over, we are now given a problem here. We're given 3x cubed minus 2x squared minus 61x minus 20. That's the problem that we have. Well, the way that we would probably try this is factor by grouping. You can factor out an x squared, leaves you 3x minus a 2. Bring down your sign. Nothing factors out of 61 and 20, so you can only factor out a 1. That leaves me 61x and a positive 20. These are not the same. So if they're not the same, you cannot use factor by grouping. Factor by grouping doesn't work. You didn't get the parentheses the same. You couldn't factor the same amount out of both. So that method's not going to work here. They've told us what one of the factors is already. So if we take that factor and set it equal to 0, we'll find out that it has a 0 of negative 4. So we're going to use that negative 4 in synthetic division. Drop down your 3 and multiply. That gives us a negative 14. This would be 56. 2 negatives make a positive. Gives us negative 5. Multiply to give us a positive 20. That gives us a 0. When we add negative 20 and positive 20, we get 0. So x plus 4 is a factor. Well, we knew that. They told us that it was a factor. So why do we care? Because we're looking for what do we get after we factor this in. We get a 3x squared, a negative 14x, and a negative 5. We go 1 degree less than what we started with. This was an x cubed, so now we're down to an x squared because we divided x out. So to factor this apart, 3x times x makes 3x squared. 5 and 1 would make negative 5. But the question is, where does the 5 go? Does the 5 go with the 3? Or does the 5 get multiplied with the 3? By putting the 5 here, 3 times 5 is 15, a negative 15, and a positive 1. That gives us 14 for the middle and negative 5 for the end. Don't forget your other factor of x plus 4. So that's an example of factoring by guess and check. You could also say what multiplies to be negative 15 and figure those out and factor by grouping to make the same factors. Here they tell us what the 0 is. We don't need to do the opposite if they give you the 0. Over here it was x plus 4 is a factor. We needed to figure out the 0. Here they give us the 0. So we know we're working with 10. So 4, negative 25, negative 154, and 40. So we bring down our 4 to get 40. That gives us 15. That gives us 150, adds together to be negative 4, which is negative 40. And we got the 0 like we wanted to. So that leaves us with a 4x squared, a positive 15x, and a negative 4. Okay, there's different ways we could factor this one apart. It looks like there's going to be a 16 and a 1 involved with this. Not quite sure which order that's going to be, so I'll show you in factor by grouping another way that we can set this up again. We know to multiply to be here, we're going to say negative 1 and 16, negative x and a positive 16x. Factor the x out, we get 4x minus 1. Factor the 4 out, 4 times 4 and 1. So we get x plus 4 and 4x minus 1. Don't forget, okay, now they're asking for zeros. They didn't say factors, they asked for zeros. So if 10 is a 0, We're also going to say x plus 4 equals 0, so we got our 0. And 4x minus 1 equals 0, so 1/4. Those are where it's going to cross the x-axis. So when we look at the last problem, we're going to treat it in the same method as this one, where we have to factor it apart, find the zeros to graph this out. So we first have to see, can we do this by factor by grouping or not? That would definitely make it nicer if we could. Factor out of 25, we'd be left with x and a positive 1. So yes, we got the parentheses the same. Now we can factor this apart into plus 5 and minus 5. So this gives us the zeros, the distinct zeros of negative 5, 5, and negative 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And also at negative 1. So because this is a third degree, we know they're going to go in opposite directions. Because it's a positive leading coefficient, that tells us that this is going to go in that direction. The odd degree tells us that this is going to go in the opposite direction. The rest of it just tells us that it's going to whirl through here. So clearly, as x approaches negative infinity, our f of x is going to go to negative infinity. It falls. And as x approaches positive infinity, moves to the right, the function is increasing. So we'd like if you would write the equation with your graph.